All right, here is some bonus material, I guess, from chapter 3.1 of PreCalculus OpenStax. In this chapter, or this section, I suppose, we learned about complex numbers for the first time. And it kind of had you shift what you thought of as a number, right? Apparently, numbers can be more than what you thought they were. And that kind of leads to really what a number is and what constitutes a number. And so kind of on that note, I want to give you a brief history of numbers. Unfortunately, this history that I'm about to tell you is not true. At least the history part of it is not true. Everything I have to tell you about numbers will be true. But this way that I'm going to come up with all the numbers isn't exactly how things happened. But this isn't a history class, it's a math class. You don't care about the history. You don't care if I lie a little bit about where things come from, as long as everything I tell you mathematically is correct. So that's my hope anyways. So here's a brief history on numbers. Our story begins way back in the day. I don't know, like caveman time, I guess. Back in caveman time, I am going to tell you that all they had were these things called natural numbers. So picture a whole bunch of cavemen sitting around a fire, and they're like, there's 3 stones sitting there on the ground, or there's 5 sticks in our fire, or there's 8 dinosaurs running around. I don't know that dinosaurs and cavemen ever lived together, but whatever. In the Flintstones it happened, so we can pretend that it happened. We got dinosaurs, cavemen all sitting around, and they got numbers. But the only numbers they have are what we today refer to as the natural numbers. And natural numbers are essentially the positive whole numbers. So they don't have a 0, for example, because they didn't need one. They're just talking about how many stones are around the fire. Then have negative numbers, because what the hell would that mean in terms of stones and fires and sticks and dinosaurs and such? So all they have is natural numbers. And in my little history, I like to pretend that they sat around doing algebra, which might seem kind of stupid, but fine. They're sitting around doing algebra. There'll be questions that they can answer. Maybe I'll make lists here. And there'll be questions they cannot answer. And so in caveman time here, somebody could ask, I don't know, someone's sitting around a fire and gives you this question right here. And some really clever caveman, I don't know if they do the same algebraic techniques we do, but somehow they solve and they get x equals 2. And they're pretty happy. And someone's like, oh, cool, we can do algebra just with these limited numbers we have. And actually, that's not true, because some other caveman might give you something like, I don't know, 2 plus x equals 1. Can't answer this one. You're like, nah, I'm pretty sure I can answer this one, right? X would be equal to -1. No, it's not, because -1 isn't a thing. It's not a number. Right? These are the only numbers we have. The answer to this equation is not one of these numbers. So at this point in history, they could not answer this question. 2 plus x equals 1. This was, I don't know, undefined, I guess, to use modern parlance. This isn't a question, solve for x here, that cannot be answered by cavemen and dinosaurs and whatever my little scenario is here. So what are you going to do? Well, our story is not going to end here. What we're going to do is we're going to enlarge what we think of as a number. So instead of just including these natural numbers, we're going to keep all those numbers. They're good numbers, but we're going to make our set larger. Our new name for numbers, we're going to call, it's what we currently refer to as integers. And integers include all of these natural numbers, but they also include 0, -1, -2, and so on. So they include all whole numbers, whether those whole numbers are positive, 0, or negative. And now we have integers. And the good news is all of a sudden we got an answer to this question. 2 plus x equals 1, solve for x, no problem, it's -1. And that is an answer now, because now we got these integers. Unfortunately, can't answer any algebraic question. I don't know where we are. Maybe we're out of the Stone Age or caveman days or whatever. But there's people sitting around somewhere doing algebra, and while they can answer this question, they cannot answer, I don't know, like this question. No, they could answer that one. How about this one? Couldn't answer this question. You're like, well, I can answer this question. I can subtract 2 from both sides of the equation and divide by 3 and do some clever algebra to figure out that x would be 1/3. That's true. X equals 1/3 is a solution to this equation, but it ain't a number. So at this point in our history, they can't answer this question. This is undefined. There are no values of x. There are no numbers, if numbers are integers, that answer this question. So what do? Well, you again make your set of numbers larger. Say, all right, I guess I'm going to have a bigger set of numbers. Bigger set of numbers better still include these numbers and these numbers. But now we got to include some new things. Namely, we're going to include fractions. Our new name what we currently call these numbers are the rational numbers. And rational numbers include everything here and here, but also fractions. So for example, 1/3, -1/5, 2/9, whatever the heck you want. These are all rational numbers. And what we've done is we've expanded our set in terms of what we think of as a number. Now we can answer questions like 3x plus 2 equals 3. No problem. Do some algebra, answer that question. Unfortunately, our story does not end here. Because I can ask you a question like, I don't know, x squared plus 1 equals 4. It's a great question. And you might be able to answer this question. In fact, you might be able to come up with 2 separate answers to this question. But at this point in our history, nobody can answer this question. Because the answers to this question, the square root of 3 and the negative of the square root of 3, are not rational numbers. And that you'll just have to take my word for. That's something you'll prove in a higher level math class. If I get the time, maybe I'll make a video because it's an interesting proof. It's not something that's beyond the grasp of a pre-calculus student. But usually you don't learn proofs like that. The teacher just tells you that, hey, the square root of 3, for example, that's not a rational number. You can't write that as a fraction. No matter what number, whole number, you choose to put on the top or the bottom of your fraction, you will not get exactly the square root of 3. It's kind of interesting. So you can't answer this question. So, well, I guess I should stop there. So this is still unanswerable, so I got to make this one set bigger, and I guess I need new colors, so hang on a second. All right, so I'm going to expand my numbers one more time. And I'm going to include those numbers that cannot be expressed as a fraction. And to do that, I will change what I call a number into what is currently referred to as real numbers. So to include more things I'd have to include, like, I don't know, the square root of 3, for example, the negative of the square root of 10. Pi, for example, is another one that cannot be expressed as a fraction, and that's, again, just a trust me thing. Same with e, that can't be expressed as a fraction. But if I add all these things in here, I can answer more questions. One thing I could answer would be x squared plus 1 equals 4. No problem. I'd say it's the square root of 3 would be a solution. The negative of the square root of 3 turns out to also be a solution. So I'm in pretty good shape and I'm feeling pretty good, and this is where our class picks up. We're back to present time. We're right here. Here's the number. Purple things are numbers, and we can answer these questions. And then somebody comes along and they asks you, okay, what about x squared plus 1? How about x squared plus 3 equals 1? Can't answer this question. Right? There is no number that we can plug in here and solve. It doesn't work. Right? There's no real number that'll be a solution to this equation. And the reason why is, think about what x will be. You're going to put something in here. I don't know whether it'll be negative or positive, but you're going to put something in here. Any number, as we define numbers right now, these purple numbers, when you square it, is positive. That's a bit of a lie. 0 squared is 0, and 0 is not positive. But if you're a positive number and you square, and you're squared, you become positive. You stay positive. If you're a negative number and you're squared, you become positive. So worst case scenario, the smallest this can possibly be is 0. But that's already too big, right? If I'm adding 3, I'm going to be more than 1. I need somehow this x squared thing to be equal to -2. Well, how the hell am I going to make this thing equal to -2? We're going to expand our numbers one last time. And so this is what we're doing in section 3.1. We're just expanding our numbers again. It seems weird when we're doing it in 3.1, whereas it didn't seem weird before, because you take all this for granted. You're not sitting around a fire with dinosaurs and think about these as numbers. Your whole life you've probably thought about all these things, at least these first two. Well, I don't know. I don't know how you learned numbers in kindergarten or whatever. But it's at this point in your mathematical education, you're pretty familiar with all of these numbers. You're not familiar with things like, I don't know, I, or 2 minus 3i, or -5i. But to add in all these things, what you would be doing is you would change your number from real numbers to what are called complex numbers. Just like in every other step in our process here, complex numbers include everything that came before it. So 3 is a complex number, -2 is a complex number, -1/5 is a complex number, e is a complex number. But also 2 minus 3i, -5i, and I are all complex numbers. And if you allow yourself the orange numbers, you can now answer this question. So I guess this color coding was a little bit weird. This should have said x squared plus 3 equals 1 here. And then maybe in purple up here, they should have said x squared plus 3 equals 1. Because really, it was with the purple numbers, we could answer this, we could not answer this. With the orange numbers, we can answer this. And that ends our story. These are as big as numbers are getting, at least in this point. I'm going to make another video on a whole nother set of numbers called quaternions, which are a step beyond complex numbers. But that's getting a little bit crazy. For our purposes for this class, this thing ends here. Often we'll just be dealing with the purple set. But once in a while, like in section 3.1, we're going to add in these numbers and change what we think of as a number, which seems like a really weird thing to do, but it really ain't that weird. It's happened a whole bunch of times in my fake little history. So I'll end this here.